Simons, and welcome back here. I hope you liked every bit of razzle dazzle we have on the videos now. Keep an eye out, as we have apps and we have skills and we have friends, and there'll be even more fun stuff coming. Now, today I don't have any shout outs for anybody because we haven't heard much back from anyone this week. Unfortunate, but presumably everyone's been out in the sunshine. Well, we have a great lesson today and some interesting things we're going to do. Firstly, I'm going to show you what we can do with the RoboMinds Academy and some useful skills you can use controlling the robot. Secondly, I'm going to show you how that could translate into how people use this in the real world, how people use this to make a lot of money at a job controlling a robot, just like we're doing on our lessons. Thirdly, we're going to talk a bit about some of the things we're going to be doing in the future. Next week, the week after, we have some interesting and very in-depth, very sophisticated programming skills I'm going to teach you. And guess what? They're not that hard to learn. You'll be pleased to know. Furthermore, not just that, they take work away from you in programming. So you can write code, you can use it later, you can use it in different programs, you can modify it in one place, and it just works in other places. You can debug it in one place, that can be used and rolled out to other places. So saves you lots of time, saves you lots of effort, saves your employers lots of money, and that means bonuses in your pocket when you have a job. But first things first, if you have gone on the RoboMinds Academy and you've created an account like I have, you'll see that you'll be able to log in and you'll be able to go there and go straight to some cool programming. So I've come here, just loaded up the site, gone straight in. I've clicked here on the third little dot, so we've come to just this ordinary screen at the start. Now, for your homework this week, I want you to use this screen. I want you to scroll back out a bit. And I want you to draw squares around all three of these objects. So there's two benches here, there's a palm tree here, there's a palm tree down here. I want you to use that to draw squares where they are. Now, how do you say, wait a minute, Mr. Ali, the robot drives, it doesn't draw squares. Oh, I beg to differ. So what you want to do is come down here and have a look. You can see that there are basic instructions. And in the basic instructions, there's your forward, backward, left, right. You can pick up the green object. You can put down the green object. And one of the challenges is take the green object from one place and put it in another, or you can eat up the green object. Might be tasty, kind of like a kiwi fruit. But then down here, you can see you can paint white, paint black, and stop painting. And I'm going to use those today to show you how to draw a square. And that's it. So we're going to start off up here in the code. I'm going to say forward. Go forward 3. Turn right. Go forward 3 again. And then, if you see, I'm going to copy and paste this code. Now, next week, I'm going to show you how to write code that makes us do this by itself. And the first bit of code I want to write is to paint white. So, similarly to something you may have seen in Scratch, you want to put the paintbrush down first, and you have to tell the robot what you want it to do. Secondly, I'm going to have you go forward 3 squares. After that, you're going to turn right, go forward 3 squares again, turn right, go forward 3 squares again, and do this until you draw a square. So let's see how this works. How are we doing? If I run my program, it's going to start, one thing to keep in mind, it's going to start from the starting base right here. And for your homework, keep that in mind too. That's an important factor in how you write your code. So he puts his paintbrush down, goes forward 3, paintbrush down, forward 3. Oops, ran into an object. Goes down, forward 3, paintbrush down, forward 3. Oh, look there, Mr. Howie made a mistake. That's no good, is it? So we want to alter this a bit. I can't run into my object there, can I? So let's go forward 2, then go forward 3, 3. And at the end, let's see what we get. So I just put this in. I'm going to have to make another turn, but the nice thing is I'm going to have to turn right. So let's try it again. I'm going to erase it, start from scratch, see how we do. Forward 2 instead of 3. Go across 3, come down 3, come across 3, and we've overwritten ourselves. So we've successfully got a square. But what we want to do on the very last step, we don't want to create too much work for the robot. In the real world, a robot has a limited, it's a machine, it has a limited lifespan, it doesn't want to work too hard, we don't want to waste paint on the floor of the factory or the warehouse or whatever. So, the very last step we want to do is we want to make sure we only go forward 1 on the last steps. Let's try it one more time and see how we do. Let's get a square, off we go. So we go up 2, turn right, go forward 3, turn right, go forward 3, turn right, forward 3 again, and on the last step, forward 1, yes, perfect. That's how it's done. So, we've successfully drawn a square, we've used the least amount of code with the least amount of steps for the robot to do the square. Let's see how this plays out in practice. Say you got a job controlling robots, and you had to code up how the robots function, how the robots interact, and what the robots do. Let's have a look at an actual place in a warehouse where a robot does work. So here we are inside the Ocado warehouse down in Andover in the West Country. So when people buy an Ocado order, Ocado sends off the electronic request to the warehouse. The warehouse is always getting groceries in, and they're getting in carrots and milk and bottled water and tins of soup, etc. And they all go to different places. And these robots go and select these groceries. They go along, and if you see on the floor beneath the robots, there are people's packing crates with their grocery bags inside, and the robots drop the food and the groceries and the water and the drinks and whatnot into the correct shopping bag, and they know specifically where it is. In the crates, there are 3 shopping bags. 1, 2, 3 is one in the middle, one on the right, one on the left, and the robot knows where that goes. So someone somewhere has to program this to drop the groceries specifically into the place where they have to go. And then once this happens, another robot takes the crates off to the truck, and that's delivered into the depots in London and Manchester and Birmingham. And from there, they take the crates to the vans which drive off to your house. And Ocado say that from the time a farmer picks the carrots, takes them to his wholesaler who takes them directly to the warehouse, that carrot could have been in a farmer's field that same day that you get it into your in your shopping at your house, which is amazing. And this is all made possible using programming, using software that interacts with robots. So it's a real-life example of how robots can be controlled by software, how someone could actually get a job that controls software very similar to how our game works, and they can have a lot of fun and make a lot of money doing things that you're learning in year 7. Does that make sense? Does that give you a bit of impetus and incentive to say, let's do well in Mr. Ali's class? There can be good things out there for me. Now, what we want to think about in terms of the future is that we're going to be learning some things beyond just drawing a square. So, tonight, when you download your homework, what I want to do is that you draw a square around each of these objects here on the screen. Draw a square around the palm tree, draw a square around these wooden benches, draw a square around this palm tree, starting from here, and do so with the least number of lines of code possible. Now, I've done this already. I have I've uploaded the graphic of that to your homework, and I've done this with 24 lines of code. Anyone who can do it with 24 lines or less, and it's the first one in, gets a golden ticket. So if you take 25 lines, take 26 lines, the first person in with the least amount of lines gets a golden ticket. The next people after that with the same or less amount of, amount of lines will get hub points for yourself and your house. So let the challenges begin. But if we scroll down here, let me show you the screen. If you scroll down here just a little bit, there are some other things we want to look at. We have loops, where we can make the software loop continuously until it achieves something. We have conditions, so the software does something until it meets a condition. We have logical expressions, so true, false, and or not. We have procedures, which are superb because it's writing little subprograms that you can use lots of times. You can write it once, use it over and over again, modify it a bit, use it in a different program. I'm about to teach my Python programmers in years 7 and 8 how this works really, really well and how that makes their life easier. We have arithmetic operators, so you can add, subtract, divide, multiply, and you can use other maths functions. So when we learn Python later on, you can find out that all those really hard geometry problems that you do and some of the calculus, you could create a program that just does that for you. Easy peasy. And finally, we're going to look at variables. So a variable is just like it says, it varies, it can change. It's something that you remember for now, and then it might change to something else, but you can use these in programs. I'll explain all about what that means, and we'll talk about that next week. So without further ado, I'm very pleased you're here. I'm very pleased that you, some people are making an effort and doing really well, and I look forward to seeing what you have for me with your challenges. So that's Mr. Ali, over and out. Remember what we're doing, remember how to do it, and we'll see you next week.